Hi, welcome to the lecture on Chapter 1, Introduction to Linux. In this chapter, we're going to look at what's the purpose of an operating system, outline some key features of the Linux operating system, talk about some of the origins, different versions of it, common uses. Linux is more used than any other operating system out there. Now, what is an operating system? Well, an operating system has two basic functions. It basically controls the hardware, the physical components inside your computer, your phone, whatever the case may be, and it's a software, a set of instructions, programs that allow the interface between you, the user, and the hardware. So it allows to manipulate data. So it kind of pretty much gives you all the rules to get what you want out of your head into something to have the computer, the physical hardware, do something with the data that you have stored on that system. Now, some of the hardware components that, if you remember back when you took maybe your CCC&TI class, you covered a few of these things, but hardware components usually contain a central processor, CPU, a physical memory. There are different types of memory, but one of them is random access memory, RAM. There are hard drives. There are CDs, DVD players, flash drives, SD cards, sound cards, video cards, circuit boards. All of these pieces of hardware are controlled by your operating system. Now, there are two types of programs that are executed on your computer. One is the applications that you're working on, Word, PowerPoint, and then it's the operating system software that actually controls the hardware. So you got two different types of operating software that's being used on most computers. Now, there's a piece of software called the device driver. Actually, it's software containing instructions on how the operating system is going to control or interact with a specific device, whether it's a CD player, whether it's a flash drive, keyboard. That driver tells the software how the operating system is going to interface with it. The user interface of most application programs, it's what you see. And you've seen user interfaces as long as you've worked with computers. It's your way of interacting with the operating system. The most common is there's two common types. There's a command line prompt and a graphical user interface, a GUI, GUI. Now, most of us are familiar with the graphical user interface. This class, we're going to spend most of our time in command line prompt. So if you've taken a networking class, like a NOS120, you're very comfortable with command line interface. If not, or if you're taking NOS120 at the same time, you're going to get very familiar with command line interactions versus a point and click, drag and drop function that you see in your graphical user interface. Now, the role of operating system, this just gives you a graphical picture between hardware, operating systems, application, and the computer user. So these are the four different layers that the operating system plays with. So you see it's right in the middle, and it's the interface between hardware and you, whether it's the applications you're running or you're interfacing to it. Now, the graphical user interface, you can use with a keyboard, with a mouse. So it's just, like I said, it's more what we're used to seeing. If you bring up Windows, that is a graphical user interface. Now, there are sometimes system services that are handling system-related tasks in the background, printing, scheduling programs, getting access to a network. So when you first boot up your computer, it's out there trying to get access to, let me find out which printers I'm tied to, if there's any programs that are being scheduled, what network am I tied to? Now, this is an example of a Linux graphical user interface. It looks a little bit different than what you use, unless you maybe, if you're on a Mac, it may look similar as far as look is concerned. But this is a graphical user interface that you may see in Linux. Now, Linux is an operating system used to run a variety of applications across a variety of different hardware platforms. It is multi-user and multitasking. So basically it means I can handle multiple people at the same time, and I can do multiple tasks at the same time. It has the ability of managing thousands of tasks at the same time and multiple users. Now, there are different versions of Linux operating system. The core component is called the Linux kernel. You want to pay attention to that word. It is mostly written in a C programming languages. So those of you that are in programming, you probably have taken a C++ class. But in this case, it's written on a predecessor to C++ in C. The software can be used to modify the appearance of Linux, but the kernel is common to all Linux versions. Now, it's important that you understand what the Linux kernel version numbers do to let you understand what version you're running with. And a good understanding of the hardware will help you decide which version to use. Now, Linux kernel versions are composed of a couple of different parts. There's a major number and a minor number. Major number indicates the major revision to the Linux kernel. The minor number indicates just minor changes to it, but based on if it's an odd or an even number, it'll tell you if it's in production or if it's in development. So if you're choosing a version, I would lean towards major numbers and with an even minor number to make sure it's a production version. So what features they're putting in have been tested and been approved to have been released for use. And then also a revision number if multiple changes to that has been done. Now here's a list of common releases back from 1991. I remember some of these first releases. But you can kind of see that dates released, version numbers, whether they're developmental or production. So the odd numbers, developmental, even numbers, production. Now, how do you get licensing for a Linux operating system? Well, luckily for most cases, it's free. It's using open source software, OSS. So they're distributed and licensed so that source code is freely available. And if you want to examine it, look at it, improve upon it, go ahead. Source code itself is the list of instructions that a software development makes up. And the format and structure of that software depends on which language it was written in. Now, the implications of OSS is, one, it's developed very rapidly through worldwide collaboration. Now, granted, software bugs, errors in the code are usually identified. They're noted and promptly fixed. Features evolve quickly, pretty much based on what the users need. So you'll see these releases quite a lot. Now, we're going to some of the software we're going to look at in this class they'll be a little bit older, but only because I want to make sure it lines up with the textbook and go on from there. So just keep in mind. So it's open source. It says it's open and free to make change. Something that is a closed source application. You can't get access to the software. You can't make changes. You can't make any modifications. Microsoft or maybe some of Apple's software. But Linux software, if you wanted to, you could download the source, look at it, modify it, set it up. Of course, freeware tells you what? It's free. It doesn't cost you anything. Shareware, it's software that's initially given out as free, but after maybe a year, 6 months, whatever the licensing fee is, you'd have to pay for it. Now, there's a couple of different open source licenses. There is a GNU public license, GPL, developed by the Free Software Foundation. pretty much says, hey, this source code and any software published on this license must be freely available. The artistic license, the OSS license, allowing the source code to be distributed freely, changed only at the discretion of the original author. And the original author can choose to say, nope, I don't want you to put those changes in. Now, types of closed source licenses, most closed software are sold commercially. So Microsoft, Apple, Electronic Arts, freeware, like I said, distributed free, source code not available, shareware initially free but pay later. Linux advantages, there's a lot of risk reduction. Changes to the market, can be, time consuming, but with Linux, it's not a big deal. The support for closed software may put a vendor out of business. There are several software manufacturers out there that over time has been what we thought were the top dogs. Borland may be a good example of what we thought was the leading edge on some of the operating, compilers of the day, and pretty much lost its market share and went out of business. OSS products offer opportunity to maintain and change source code. But a lot of the advantages, it says that it reduced the risk of making changes to it. It really, because it's open to so many different people, it's definitely meeting business needs. Common software available, are on scientific and engineering software, webinar, software emulators, web servers, browsers. Take a look at if you ever played with DOS and look at a path name. So this is Microsoft DOS. And type in a path name. Tell me which direction the slash marks go. Look at the web browser and which way does the slash go. You will find that they all go from slashing to the right. They're all Linux based. So your web server, web browser, e-commerce sites are all, well, I shouldn't say all, 99.9% are Linux based. Your phone is Linux based. So a lot of different things. It is stable. It's a very stable environment. It's very secure. You don't see a lot of security releases for Linux as you do with some other operating systems. Because of the collaborative source of testing and bug fixing, it just has more eyes looking at it with different points of view, so you end up having a more stable releases. Security and bug fixes can be identified and fixed freely, and since the code is freely available and scrutinized by a lot of different developers, we can tell if there's things put in it we didn't want to put in it. Oops. Now, a partial list. Now, one of the advantages, it's flexible to run on tons of different hardware platforms, and this is just a list of it, from small PCs to very mainframe large systems. Can work on mobile phones, embedded devices. You can run Linux on a flash drive. Try running Microsoft Windows on a flash drive. Now, it's easy to customize. Once you understand the inner workings of the operating system, you can use Linux as an internet web server, compile the kernel, run it. The results are much faster. You can choose only to install packages that you need. You don't get every application or every service running on your platform as you do with like Microsoft. So it comes up relatively quickly, and because you're not running a lot of different applications in the background. There are different programming languages to run as a shell. We'll play with a few of those this semester. Now, more advantages, definitely tons of support. Even though it's all not written by multiple companies, there are definitely tons of information, frequently asked questions, how-to documents. that help run. There's news groups, user groups out there. So you're not really left out to your own devices. Advantage of Linux is a cost reduction. It's free. So because it's less expensive and there's no other association and there's so many different varieties of it, it makes it very cheap. The largest cost may be the people that it takes to be hired with Linux background. And if you're getting in the technical field, any kind of knowledge of Linux is a plus. So, not bad. Rough idea of how to reduce your costs. You can just tell operating system free, greater than free. Administration, it's low. Give me cost, try to fix bugs on a Microsoft Office or Microsoft operating system, Microsoft Windows operating system. Additional software, most of it's free, it's open source. Cost of upgrades, low or none. If you want to buy different packages with Microsoft, what is it? It's pretty pricey. A little bit of a history of Linux. Started back in the mid-60s. Multics project started. 69, AT&T Bell Labs invented Unix, UNIX. Rapid, a lot of development all the way through until the mid-80s and into the early 90s. You started getting the Linux, Linus Torvalds created Linux back in 91 and then kept moving on approximately 7 years to get its first million, approximately 7.5 million users in relatively 7 years. That's not too bad. You get some other information, but right now you're 20 years, 70 million users, excluding all the Android phones. So guess what, Android users? You're using Linux. Unix was a multiplexed information. Started with Multics. First true multitasking, multi-user. Because back then, some of the early mainframe softwares was not. Written in C, it was portable. AT&T Bell Labs sold the source code to several different companies, each had its own flavor of Unix. You would get Berkeley, some other flavors, Oracle, Solaris, used to be Suns. You got Hewlett Packard's, IBM's, Macintosh, Mac OS, iOS. So guess what? Apple's. So you already saw that back here. You got Android. Here you're saying, Macintosh, all the hardware platforms, all the iOS that Apple's running, Unix, Linux based. Now, hacker. You all want to be hackers, don't you? Well, basically it's a person who attempts to expand knowledge of computer through experimentation. Now, how they experiment, but Linux is a good platform to do that. Now, a cracker is somebody who legally uses computers for personal benefit. And you've got a person, Richard Stallman, was a famous hacker that worked at MIT and formed the Free Software Foundation, basically to encourage free software development. Now, the GNU project was also started by Richard Stallman, promote the free development of operating system, led to, GNU, the public licensing, free distribution. This culture kind of set the stage for Linux. So they started with Unix and started building this. I need to get free software. I don't want to have anybody in control of it. I want all the people that need it and want to use it and experiment with it. Then it ended up being but it set the stage when Linux was developed. Now, Linus Torvalds in 91 published under the GNU license, so that license was in place, and the kernel was developed collaboratively and centrally managed. So, and they added on add-on packages, the distribution. Distribution, all it is a collection of software containing the kernel and associated libraries. And of course, any add-on software. A couple of examples is Red Hat and SUSE. Are a couple of examples of those. Now, Linux is simply a byproduct of that OSS, that open source development. And since 2000, it's been interested and embedded in Linux. Linux OS's smaller devices, mobile devices. It's got more to application development expected the next decade than pretty much anything out there. Now, of course, distributions do appear different on the surface, but they all run the same kernel. Some distributions, large number of server-related tools, such as web server, database servers, but most of it can be customized to suit whatever you want it to do. Linux's environment, X Windows, is a combination of window management and a desktop environment. It has the look and feel of a Linux GUI. Two competing GUI environments are the GNU Object Module environment, or GNOME, or the KDE, the K Desktop environment. Some distributions include specific languages, Turbo Linux, support for Japanese, Chinese. Here's just a picture of the GNOME desktop. Here's an example of the KDE. We're going to look at both of these this semester. Definitely next week we'll look at installing Fedora and go from there. Package Manager is just software that installs and maintains your software. Tarball is compressed. It's like a zip file, archive of files containing scripts and install it and stuff. Package Manager's common method of installing packages. Here's just different distributions: Red Hat Linux, SUSE Linux, Slack Linux. They all have different features, different runners, designed for different platforms. Like I said, we're going to be looking at Fedora as one of the applications that will be one of the distributions we're going to be looking at. Debian, and I think the other one we may do is Ubuntu. But each one gives you different flavors, different purposes, and different hardware platforms they were written for. So you have to pick and choose which application, based on what hardware platform, what service you're trying to offer. It's what you get to pick and choose. Now, some of the common uses. Since it can be customized, provide services across different companies, different situations, workstation services on a local computer, server services, like I said, web servers, database servers. We're going to be installing a workstations type service with using VMware workstations, so you can actually install a version of Linux. So other common uses: internet servers, file and print servers, application servers, cloud, supercomputers, and mobile devices. Of course, your internet servers, because I said the direction of that URL definitely gives you different types of mail servers, routing, FTP, that's file transfer protocol services, security services, web, news, DNS services. All of those things are running with Linux. Now, if you look at types of services, mail services, you got a mail transfer agent. It's just an email server. Several different types. You've got a mail delivery agent. You've got a mail user agent. Several of these are stuff you're familiar with. Some of them you don't. But just know that they're services that are off there. Internet servers for routing purposes. Basically, how do I connect between networks? File transfer services basically means file transfer protocol. I'm just going to communicate. I'm just going to send data between one device to another. A lot of it's used for transferring larger files than a text message. Security services, firewalls, proxy servers. Firewall protects companies from outside intruders. Proxy servers request internet services such as websites or file transfer protocol sites on behalf of another company. Web servers, you got web services, web servers that host information. They can process programs known as common gateway interface scripts that connect resources on a network that are not on the internet. Or if you've looked at some of the security options, you've seen single socket layer, SSL, or transport layer security, TLS, are just ways of securing your network. We'll get a little bit more into that later. Now, many open source web server packages are available, and probably one of the most widely is the Apache web server. So just keep in mind that is very widely. I use it in my Web 182 class for their development platform. News services, news group development, news groups, how to developers, DNS servers. Basically, that's just what it converts. When you look at an IP address, an address that allows you to physically identify devices on a network, most of us don't remember numbers well. So if somebody told you I'm going to 192.168.10.10, that would leave your mind relatively quickly. But if you're saying I'm going to www.CCC&TI.edu, well, DNS says I want to change that name into that number. Machines like numbers, people like words. DNS does that translation. There's some identify a fully qualified name, just gives you a full name. Domain DNS is a name server, so it just allows it. File printers, print servers, just ways of sharing resources within an office. Application servers, database management systems. All of these servers, cloud systems, Amazon, Gmail, Twitter. Wow. Who's running Linux? Most clouds are running cloud-based storage, and OpenStack is definitely one of the most popular open source cloud platforms out there. Supercomputers run it because they're scalable. It's faster. Now, workstations, as you can tell, there are plenty of different applications that are being run. Mobile devices. Android, 79% of the phones in North America, guess what? All Linux. Google's Android 2008. So you can tell. Linux distribution, you find mobile devices. Firefox. So just several different operating systems out there. So Linux is just an operating system whose kernel and additional software freely developed and improved upon by a large community, licensed to the outside world, and allows people to find applications that are stable, low risk, flexible for most application. So there's plenty of ways out there. So hopefully this brief lecture helps you understand a little bit of the material in Chapter 1. Thank you.